And welcome to topic 3, lesson 3.1. Today we are going to talk about rigid motions as well as reflections and reflecting across different lines. So what is a rigid motion? So you see this vocab word here. And basically what a rigid motion does is it is a transformation that preserves the length and size of your angles as well as your side lengths. So if we look at this example here, we see a couple other vocab words that are of importance. The first being a pre-image, the second being your image. Your pre-image is basically your before, your image is your after, the transformation. And in this case, this would be considered not a rigid motion because our pre-image was a little bit larger looking arrow. Our image then shrunk it down. So while it's the same shape, it's not preserving the side length and the angle measure. So we cannot say it is a rigid motion. So down below, we have two more examples for you. Would this be considered a rigid motion in part A? Here's your pre-image, here's your image. And then in example B, here's your pre-image, here's your image. Is that a rigid motion? Now, there are multiple types of rigid motions, the first being our idea of a reflection. And a reflection, if we look at this vocab word, underline that, a reflection is a transformation that reflects a point across a line of reflection. So for instance, if we look at this original triangle ABC, we see this line of reflection here, line M, and we are moving the points across that line. We are reflecting it. Now notice if you have a point like point A that is on your line of reflection, it's going to stay put. If you're on the line of reflection, you're not moving. But points B and C are not on that line of reflection. And notice they are the same distance away from that line of reflection in the pre-image as they are in the image. And then same thing with point C, same distance from that line in the pre-image than it is on the image. Okay, so again, you move across that line, same distance. When we write our reflections, they are represented with a capital R. And then in here is the line you're reflecting over. So sometimes it'll be the X or the Y axis. Sometimes it's a vertical or horizontal line. Now in this case, they're telling us we have this original figure, triangle LMN, and we are reflecting it across line N. What would our reflection look like? Well, again, you want to make sure you start if M looks to be a certain distance away, M prime is that same distance on the other side. Same thing with the L, it's further out from here. L prime would be that far, and then N, again, same distance on the other side of that line of reflection, N prime. And again, these apostrophes, we call those the prime. So now we also can look at reflecting across specifically the x-axis or the y-axis as a general rule for looking at these. So again, if you look here, what we're noticing is when we take these original points and reflect them, each time our y values as we reflect them across the x-axis are changing. So we have this general rule that we look at when we reflect over the x-axis, we actually end up changing our y values sign. Now notice any point that again is on that axis stays put, -2, 0, stayed put because it is on that line of reflection. So if we look at reflecting these points across our x-axis, we have the x-axis here, and notice point C, which is at 4, 0, is on that. So C prime is also going to be at 4, 0. The others, however, are not on that line of reflection. Notice point A is 1 unit above. It's now going to be 1 unit below. So it would be to the left 3, down 1. So -3, -1 would be A prime. B was 2 units below the x-axis. It needs to be 2 units above. So we label that. That point is now at -1, 2 for B prime. Now we also can reflect across the y-axis. Again, that's our vertical axis here. Again, anything on it is going to stay put. But what we notice this time is that our x values are changing their signs. So these all are going to flip-flop to be opposite signs. When we reflect across the y-axis, you end up changing your x coordinate. Or again, we look at our pictures here. So if we have our y-axis right here, this time we don't have any points on there. But we do have, for instance, point A is 1, 2, 3 units to the left. It's now going to be 1, 2, 3 units to the right of the y-axis at 3, 1. Point B was 1 unit to the left. It's now going to be 1 unit to the right. That's B prime. It would be at 1, comma, -2. Again, went right 1 down 2 from the origin. And then point C was on the x-axis. It's 1, 2, 3, 4 units away. From the y-axis, 1, 2, 3, 4 units away. Now, the other direction, it's at -4, comma, 0. So we can see reflecting these points across both axes. For instance, if we have B, G, T, and we are looking to reflect across the x-axis, again, all three of these points are going to need to be the same distance away that they were originally. So those are both 1 unit below. G and T prime are now 1 unit above, and then B was 5 units below. B prime would now be 5 units above. So this would be our reflection over the x-axis. We would have B prime, G prime, and T prime, now located at -3, 5, -3, 1, and T would be at -1, +1. We can also then reflect the original over the y-axis. Again, notice these points have to be the same distance away. So T was 1 unit away, G was 3 units away. Now we're on those same distances on the other side. And then B was 3 units away, so B prime also. So again, when we look at these, this time for B prime, G prime, and T prime, we are changing the x values. We would be at +3, -5 for B. G is at +3, -1. And then T, we went to the right 1 and down 1 on that one. All right, now we can reflect across other lines besides the x and y axis. For instance, x equals 2. Okay, reminder, anytime you get x equals, that's going to be a vertical line through that number. So in this case, x equals 2 was a vertical line through 2. And we have our original 3 points. A was at 1, 2, B was at -1, 0, and C was right 3, down 1. And we now can reflect across this new line that's not an axis necessarily. Now, A was 1 unit to the left, now 1 unit to the right. So this would be at 3, 2 for A prime. B was 1, 2, 3 units to the left. It's now 1, 2, 3 units to the right. So B prime is at 5, 0. And C was 1 unit to the right. So now C prime will be 1 unit to the left at 2, -1 for C prime. We also can reflect across horizontal lines. So notice y equals -1. Anytime we have y equals, that's a horizontal line through that number. So in this case, a horizontal line through -1. Now what we notice with this one is that our original points, G was at -3, 0, or excuse me, -1. T was at -1, -1. B was at -3, -5. This time, G and T were both on our line of reflection. So G prime and T prime are actually in the exact same locations as our original because they are on the line of reflection. They did not move. B prime, on the other hand, this was 1, 2, 3, 4 units away from our line of reflection. It now needs to be 1, 2, 3, 4 units away the other direction. Oops, that's B prime. Erase that. B prime. So this would be to the left 3, up 3 from our origin. So -3, 3 would be the location of that point. And again, what we notice is that when we are reflecting, our size is preserved in a reflection because, again, reflections are rigid motions. So we're preserving the shape and size when we reflect. All right, one last one for you to try. A reminder, x equals 1 is a vertical line. So you are drawing in your vertical line through x equals 1. Where do Q prime, S prime, and R prime end up at? Thanks everyone for watching. We'll work more with these in class.